So now we will be starting with the PCI Express transaction layer, RTL coding, and test bench development. So the first, let's try to come up with what all things we need to implement as part of the transaction layer RTL code. I mean, it won't be a very perfect, proper RTL code, but I would rather say a pseudo RTL code that would enable us to develop the test bench and see how the transactions are flowing. Okay. Then once we do this, then we'll move on to the system Verilog and UVM based test bench development for this transaction layer. One we are implementing the transaction layer is code is from a root complex perspective. I mean, it would represent the root the transaction layer of the root complex. Okay. So first, before you develop any RTL code, what is the primary step? You have to come up with the top level architecture. Then we'll try to come up with micro architecture. Then we will come up with the interfaces, then the registers that are required for implementing this design. Then we will implement the sub blocks and further. I mean, sub block RTL coding and then the RTL integration. These all things we will be doing as part of the transaction layer RTL coding. Now coming to the test bench development, this would start off with the test bench architecture development. Then we will list down the test plan, the features and test plan. Then we'll come up with the develop the test bench components, and test bench integration, and run the test cases, and debug. If possible, set up the regression. These are all the steps that are involved in this process. Uh, So I might use an existing RTL code also as part of this because there's no point developing everything from scratch. Again, see this RTL code also what I'm talking about is something that we have done some time back, maybe a few years back we would have developed that RTL code. What we will do is in this process, if there is any updates that need to be done to that RTL code, we will do that. Okay. So first, let us come up with the top level architecture. So when I say top level architecture, we'll see what all interfaces are there, what kind of sub blocks are required into the design, all those things we'll try to understand. So the first thing we will do is list down the transaction layer features. I mean, what is it supposed to do? At the very top level, the transaction layer block is supposed to interfaces with the system knock on one side. I mean, that is through the AXI interface. Okay. And interfaces with DLL on other side. And because the transaction layer needs to buffer the data. See, generally what happens, whatever transaction it has to send, that information doesn't directly come to the transaction layer. What do I mean by that? If I take this as a transaction layer, let's say, if this is my transaction layer, and I want to, basically the idea was, one of the things processor wants to do is, let's say the use case we are talking about is the processor wants to move some image from system RAM, I mean system RAM or system disk, anything, right? It could be the SSD or hard drive to PCIe device. That is the idea. Basically, somewhere here the device is present, and somewhere here my system RAM is present. Here the image is present. That image need to be moved into my PCIe device endpoint, basically. In this case, the processor doesn't directly give the image. What it would do is, there will be a DMA, there will be some DMA which will be configured to copy the data from here and transfer the data. See, this communication happens through an on-chip protocol. There will be an on-chip protocol. It could be AXI, AHP, how it reads the data from the memory. Now, this data that you need to send here, it will happen in terms of PCIe transactions. And this is what I'm calling as the transaction layer component. I mean, the PCIe transaction, this is what is represented by transaction layer. Now, in the meantime, you know that data link layer will come, physical layer will come, and the packet will be sent on the link. On the other side also, see, if this is my device, there will be a physical layer, there will be data link layer, and transaction layer will be there. And that will get the data, and it'll process this DLLPs and transaction layer and everything. So this is all you're aware. So are you clear till this point?
Yes.
Okay. So
So
now
now
what
here the DMA will be acting as an
must,
arbitration between this memory and the PCI endpoint. It will
yes, exactly.
it
So
will
there will be a
so there will be the no direct involvement of the processor. DMA will
processor
take
will
care
not be
of the
directly involved.
transactions.
Yes, basically what happens, the processor will configure the DMA indicating that, see, this is where the data is present and this is the
Yes.
destination. You need to get the data from here, you need to transfer. Getting data
Yes.
happens through AXI or HP interface. The transferring of this data
Yes.
will happen by means of PCIe transactions.
Yes, sir. Understood.
Okay. Now,
Even now,
if you look at this diagram,
even this PCI device wants to initiate transaction also, this DMA will take care of it.
exactly. So let's take the reverse side of it. Now I've got a completion with data packet. What does it mean? It's a TLP which is carrying the data. Now what is going to happen? It will go through that physical layer, data link layer, and finally it goes to transaction layer.
Yes.
Okay. So the transaction layer, what it does is it doesn't directly give it to the processor. It won't give it. Rather, what it does is it will process that information, whatever it has processed. This will be stored into some other part of the memory RAM. And that storage will happen by means of DMA. So the DMA will take the data from here, it will store here. Because I don't have any processor to do that activity. So then
Hmm.
once it is done, the processor will be indicated by means of an interrupt saying that some data has been stored into the memory. You go and read that data.
Okay.
So this is all that is involved in this process. Now, if you see at very top level, if I draw a diagram like this, if I draw one like line, can you tell me for that block? This is our DUT. When I said transaction layer, this is the
Hmm.
design that we want to develop. How many
Yes.
interfaces do you see for this?
Interrupt interface.
Okay,
Whatever the we AXI interface or APB or AHV depends upon the bandwidth support. It
yeah,
is on chip. Uh,
yes,
and here the PCI protocol interface.
yeah. Basically, there will be three interfaces at minimum. One is this
Yes.
interface you see. One is this
Yes.
interface you see. One is this interface you see.
Uh,
There are three interfaces, right? Now you may say, what
yes.
about interrupt interface? Interrupt can be part of this interface itself because I don't want to
Yes.
call an interrupt as a separate interface, right? So on the one side, transaction layer interfaces with on one side, the transaction layer is interfacing with what? The processor by
Processor.
means of AXI interface. So I can call this as any AXI or AHB interface,
Yes.
AXI or AHB interface. To connect with what? Oh,
Processor.
or AHB. And this will be the processor. On the other side, what is there on this side?
The
A
downside it will be to the endpoint.
transmit, transmit direction, and then there is a receive port also. You know, right?
Yes.
Transaction layer will have two things. One
Yes.
is the transmit, one is the receive.
Yes.
Clear, right? Now, so here, what do I have in that case? Sorry, here I have, what is this?
Some endpoint base.
This is not the end point, I will say. This is actually speaking. This is data link layer plus everything else. This
Okay.
represents data link layer plus all other things. What is all other things? Ideally speaking, what would happen in real life? There will be a data link layer, there will be a physical layer, there will be a link,
Mm.
and on the other side of the link, there will be another device will be there.
Yes.
But see, I don't want everything. I want to represent one block which will represent all these three things, all these things. As you agree with that?
Yes.
It represents all these things as one unit. What is that everything? So this represent DLL
So
plus all
this
other things.
everything
What
is
exactly is all other?
this side of DLL, this side of file layer and the link, and another side of the file layer, another side of the data link layer, and another side of the transaction layer, and all this OSI interface, and then connected to the device B.
Exactly. So typically, what is the purpose of this is, let's say if I get memory read. Ideally speaking, what would happen in the real life if it is memory read? It will go to the data link layer. From the data link layer, it goes to the physical layer. From the
Physical
physical layer
layer.
on the lane, it will link, it will go to the
Yes,
another
link.
device. And on there also it will go to physical layer,
Another
data
physical
link layer,
layer.
and
Yes.
transaction layer. And in the transaction layer, it would have some associated memory, which would essentially
In that address, it will,
understand that it's a memory read. It will frame a completion with the data, and it will give here,
and
it
then
will come here, it will come here, and it will go here.
just
The whole point is, I don't want to really implement I don't want to implement everything like this. Rather, I will implement one comp, which is exactly what it is. It is essentially whatever we have drawn just now, like including the one layer, the other layer, everything is all represented by this layer alone. What does it
yes,
get? A memory read request. If I get a memory read request here, then memory read request will be understood by this block. This itself will frame the completion with data, and this itself will drive it, because this represents everything on this side of the transaction layer. Everything till we are talking about the endpoint also. Now, once the completion with data comes, and how this memory read, everything will be framed based on the memory information that is coming from the memory. So here, it is here. This will be the memory, or I can call it as buffer, because the information need to be stored somewhere, right? Information need to be
yes,
stored somewhere. That only then my DMA controller can get that data. So that is this one. Okay. Next, so this is my DUT, the transaction layer. Also, I can call it as DUT. What is the blocks that does it require? Let's at very top level, let's draw those block diagrams. It will require one DMA block, right? Do you agree with that?
yes, yes.
It will require
DMA.
one DMA block. I can use a just different color. What else it requires? It requires a transmit engine,
Transmit and receiving.
transmitter. And these are things that gets refined as we start working on it. This
Mm.
architecture, everything gets refined. I mean, probably what we are trying is not a perfect architecture, but things will get refined as we work on it. This is the receiver.
Yes.
What is the responsibility of the DMA? Let's write down that part of thing also. Okay. What is the responsibility of the DMA block? Is to, once the processor initiates the transaction request, the DMA controller internal to the architecture, internal to the root complex, performs DMA controller performs read or write, read to the, it could be read or write, read to the
Yes.
memory, and gets the data. This data is given to transmitter. Transmitter will refer to, will use the registered configured values, register configuration values, to figure out how to frame the packet, how to frame the TLP. That means what? It also requires one more block called as the configuration registers. Configuration, control and status registers, I would call it as. So how these are connected? Everything is taking inputs from this block, basically. Everything takes input from this block. Mean receiver, how receiver should behave, it is also decided based on the control and status register programming. Okay, even DMA behavior is also dependent on control and status registers. Okay, even transmitter behavior is also impacted based on the control and status registers. And this would give the data in this direction. Okay, this would also give the data in this direction. You can see the receiver also will give data to the DMA so that it can do the transfer to the memory. Okay, this is a very top level rough architecture. Now as you start working into the DLL, the transaction layer coding, and as you start working on it, we may get a finer picture of how to develop
Mm.
this RTL code. So this entire thing is what we'll call as a test bench. So this entire thing put together is what we will call as a test bench. Now you see on one side, to check whether this is working fine or not, we will require one RTL code, right? Sorry, scoreboard will require. So let scoreboard be this color. Okay. Okay. Now, so I think going back to the discussion, do we did now let us list down the test line, transaction layer features. See, I think it is better to start from the this order. So what are the transaction layer features? Framing of TLPs, right?
Yes.
And decode the incoming TLPs. What else it does? Transmit the TLP based on the virtual channel, this thing, right? Arbitration.
Mm.
You know, right? There is arbitration. Based on that, it should decide which TLP should be transmitted.
Yes.
TCVC mapping, I would rather say TCVC mapping. TCVC mapping and virtual channel arbitration.
And this
What else
means
it does?
which data there are a more number of incoming ports, and from which port the data from which port is to be sent is sent with arbitration of the
Uh,
port, and which virtual channel data to be sent is decided with virtual channel arbitration.
no, that is inside a switch. What you are talking is about the behavior inside the switch. Here we are talking about just this one alone. See what happens? Processor may want to do many transfers. See, from here it may wants to transfer some data here. Another part of the memory it may wants to do some transfer, right? Or
Okay.
sometimes it may want to do configuration write and configuration read.
Yes.
Tell me which one should happen first. One is configuration write read, one is memory write read. Which one should happen first?
It depends upon the arbitration.
No, it doesn't depend. Configuration write read always has the highest priority.
Okay.
So the first configuration write read will happen, then the memory write will happen. How does it work? Configuration write read is mapped to virtual channel 0. Memory write reads are mapped to virtual channel 1 to virtual channel 7.
7. Yes.
Virtual channel 0 always has the highest priority.
Highest priority. Yes.
Any
Yes.
traffic class that is mapped to virtual channel 0 will get priority more than the other traffic classes.
Yes.
So here,
Understood.
if the DMA is giving information to transmitter and transmitter has to decide which one I need to transmit. So there it will make a decision what I will have to transmit the configuration TLPs
Conf-
before I can transmit the memory TLPs.
Okay.
Okay. So this is few things. Now, what I want you to do is I want you to list down, like I want you to go through the transaction layer part of the presentation. Like you have got the PCI protocol PPT, right? In that you go through
Yes.
the transaction layer specific slides, and whatever you feel need to be further added, we will list down all those things.
Okay.
As per me, it covers most of the things because what does transaction layer does? It does the
Transaction layer,
streaming. It does.
it accepts data from this DMA, and with the DMA, it will frame a TLP packet and it will send to the data link layer. And the other
Yeah.
side, the data coming from the data link layer, it accepts in the receiving block and decodes all the ECRC and TLP digest or whatever, and it decodes the information and it will send to the DMA again, and DMA will take care of where this data should be sent.
Oh, yeah, you got it right. So for now, we will move on to the next topic. In the meantime, because I don't want to spend a half an hour just looking into it, because this is something we can update on the fly. I mean, as we move forward. Okay. Now
Yes,
let us move
okay.
on to the next topic, next part. Do we have the top level architecture?
Yes,
What is top level architecture? The one you see I have drawn in this diagram
we
is
have.
itself is the top level architecture.
Yes,
I mean, it
yes.
will have a DMA, it will have a transmitter, it will have a receiver, it will have a
Hmm.
control and status registers. This is the top level architecture. Okay. There maybe there will be one AXI specific interface will be there to understand the incoming transactions.
Hmm.
Okay. These kind of things will be there. Now, talking about the next topic, micro architecture. Micro architecture is the difficult part of it because it is something a core RTL engineer only can really explain that micro architecture. I mean,
Okay.
what all sub components will be there? Like going into the transmitter, what all sub components will be there? In terms of one packet framing block will be there, one CRC generation block will be there, one
Yeah.
arbitration block will be there. So that is called as micro architecture. What exactly is micro architecture? Going into each block, what sub blocks will be there into? Basically, it's going to the second level and third level. See, at the first level,
Hmm.
what we have?
We have only the top module, which is the transmitter, and
Yeah,
inside the transmitter,
basically
what are the different blocks we have is the microarchitecture.
micro architecture receiver. Then you have the DMA engine,
Configuration, yeah,
engine.
control and
Then you
status
have
registers.
configuration and status register block. Now, what is
Yes.
micro architecture would be? What
What are
is
the
there below
different
each of
blocks inside every single top level architecture
exactly
block?
right? Going into the transmitter, what all things do you believe do you feel will be there in transmitter? Transmitter at least requires TLP framing block, right? You need to frame the TLPs, right?
Yes.
What else does it require?
ECRC generation block.
CRC generation block,
Yeah, CRC
ECRC
generation.
generation block.
Hmm.
Yeah. What else do you require? Do you think it requires the arbiter, the virtual channel arbiter?
VCR.
Because
Yes.
it is where the decision happens, which TLP need to be transmitted. And what else do you think it requires?
Maybe there is also a buffer in the transmitter.
It won't buffer won't be there basically. See, for all purposes, oh, I think small buffer might be there. Mm, I think
First to send the
no, no,
data
buffer
to
won't be
the data link
buffer. No,
layer.
no, buffer won't be required because the data comes on the fly. You frame it on the fly.
Okay.
Okay, so it doesn't require any buffer.
Okay.
Next, what else do you think it will require? Why these are all important? Because eventually this will become one very log code, very log
Hmm.
module. This will become another very long module. This will become another very long module, and eventually they all need to be integrated to get the transmitter block.
Yes.
Okay. Similarly, receiver. What do you think receiver will require?
Same this ECRC extraction
TLP
module.
decoding
Uh,
block, right?
TLB decoding block.
Decoding block and
Header and
TLP
payload
checking block.
decoding block.
TLP field checking block.
Hmm.
I mean, you need to check the integrity of the TLP, right? Whether it's good or not. Then
Yes.
ECRC uh, checking block.
Checking.
Then what else do you require? That's all. I think VC arbitration is not required because you already received, right? So there is no arbitration required. Similarly,
Yes.
DMA engine, what does it require? It is just a component, right? Basically, it will have some FIFO inside it.
Yes.
DMA engine is nothing but some group of FIFOs, right, into which you store the data for various channels.
Hmm.
FIFO corresponding to various channels. Now, CSR block. What is CSR? Control and status registers. Can you tell me what is the purpose of control and status registers?
Configuration block. It will be divided into two blocks, and one will be useful for, and it will be divided. The division will be based on if there is 256 bytes register space. It will
Not
be
like that.
divided into
Register for
92 and 164.
configuring the transaction layer behavior. CSR block is nothing but the registers for configuring the transaction layer behavior.
Okay.
I will give you a simple example. You have a washing machine. A washing machine, if you just switch on the motor, switch on the power button, right? It won't
Hmm.
work. You have to change the knob into specific mode.
Yes.
And then accordingly it starts working, right? The
Hmm.
same thing is with CSR block also. Before you can do anything into the transaction layer, we
Transaction
need to
layer.
program the registers that are present in the transaction layer, that is control registers that will configure the transaction layer behavior. And while you are
Okay.
doing that, there are status registers which will indicate which indicates the status of the transaction layer. I mean, yeah, like what one of the registers will tell, I have received so many TLPs.
Hmm.
It'll indicate that. So those kind of registers will be there, like in say, simple
Okay.
example in washing machine, it'll tell that now the washing is done, now the rinsing is happening, like that, right?
Hmm.
Now the washing machine is spinning. So various
Yeah.
things it'll indicate, right? Those are like the status registers. Okay, so
Yes.
this is
Okay.
a micro architecture. I would not say, I mean, we are very complete here because this is something probably a RTL design engineer can be able to talk more deeply into it. But at very
Hmm.
top level, this is how it should look like. Next, once microarchitecture is done, what all interfaces are there? These are all important because when you are developing the RTL code, when you are developing test bench, this level of study is definitely required. What are all interfaces are there? Can you tell me? One is the interface with the
And
processor,
interface with the processor, interface with the memory, interface with the below layers,
interface with the data link layer, and
other
components,
components,
other components in till the endpoint.
endpoint.
Endpoint and endpoint memory also. See, we are also talking about endpoint memory also because when
Hmm.
you give a memory read, where does the data come from? The read data comes from the endpoint memory only,
Endpoint memory. Yes.
right? That is
If you
one thing.
want to write also, we should write to the some address in the endpoint memory.
Exactly, yeah. So interface with the processor. Now we have to understand, should we go with AXI interface or should we go with AHP interface or APB interface?
Like see.
So definitely APB is ruled out
Yes.
because APB doesn't give the required bandwidth for the PCI
PCI.
level of transaction. Now I can go with either AXI or AHB, but preferable would be AXI. We'll go with AXI protocol. Next, interface with the memory. Here also I can use AXI interface because at the
Yes.
end, this also should happen at very high speeds, right? I mean,
High
the bandwidth
speeds.
should be very high
Mhm.
here. So I can use AXI interface. But see, from a transaction layer perspective, transaction layer acts as a slave to this interface. Do you agree with this?
Transaction layer acts as a slave for the interface.
Which interface?
Yes.
Interface with the processor. If you take this,
Processor.
processor
Hmm.
acts as a master,
Yes.
and this will act like a slave.
Yes.
Talking about this interface, can you tell me who acts as a master?
Transaction layer.
So this acts as a master. Who acts like a slave?
Memory.
Talking about this interface, who acts as a master?
Maybe this depends upon this read or write. Maybe
Yeah, no.
the
During transmit,
during transmit it will act as a
transmit,
master.
my transaction layer will act like a master.
Yes.
This will act like a slave.
Yes.
During
And
receive,
in the
this
receiving
will act.
side, this will act as master and transaction layer receiving side as a slave.
This level of understanding is also definitely required because that will tell you how this code should be developed.
Yes.
Okay, this thing. Okay, next that is about interfaces. Interface with DLL, it will be what? I can't use.
PC.
Can I use AXI interface here? Tell me
No.
why you can. Why you can't use
Because
AXI?
the transactions are in the packets.
Yes, that is one is in terms of packets, and the second thing is it is internal into the PCIe architecture, right? So inside the PCIe architecture, you don't use AXI protocol. It will
Actually.
be some
Hmm.
custom protocol. I mean, some custom protocol. Custom protocol means what? It is specific to the company which is developing this PCIe article code.
Hmm.
Let's say I'm developing. I may define a protocol, data, valid, and ready. That's all. I will
Hmm.
keep only those many that much information. Here also, receive data, receive valid, receive ready. Like that, I'll only keep. Okay, that is what I mean by custom. Custom means the protocol which I have developed specifically for this requirement. Okay.
Okay.
I hope you understood the interfaces now. The next thing is registers. I'm talking about the control and status registers. How what all registers are required basically. If talking about control registers, what registers will be required? Can you tell me what registers will be required?
Configuration or
No, configuration in sense. We need to understand what type of registers will be required. We may need to configure. So the control registers, what will be required? Let's try to understand. So you may want to configure the virtual channel priority, right? Arbitration priority. That can be one type of registers. What else could be the registers? Uh, right now, I am not able to think. Maybe
is there any
for the
traffic class? Maybe
traffic class mapping, VCTC mapping may be there.
VCTC mapping. Yes.
Mapping might be there. So these kind of things we have to list down.
Memory
And
mapping.
memory mapping, we'll discuss. Memory mapping probably won't be there, but we'll discuss that part. I mean to
Okay.
say, we definitely need to work on this part also
Okay.
because uh, th- through this only my processor will program these registers and to control the transaction layer behavior.
Yes.
Next, once registers are done, what is a sub block RTL? I think this is about RTL coding. Now,
RTL.
does it require any state machine?
Yes.
Tell me. Can you tell me, does this design require any state machine?
Yes.
100%, right? We can't have a, a complex sequential design, a complex sequential design. See, this is a sequential design, right? It's not
Not
combinational
a
design.
yes.
Without FSM, without FSM. FSM is compulsory in every complex sequential design. So here, how do we start with the FSM? I mean, what is the starting point for an FSM? The starting
Ideal
point for
state.
FSM is, let's say, reset state or ideal state.
Yeah,
Let's say
ideal state or
ideal
reset state.
or reset state. Then what is
Yes.
the, I think now we have to think about the possible flow, how the flow happens. That will give you the FSM states. See, let's talk about the transaction layer design flow. So what happens? It was in reset state. I mean, power down. You have applied the power. Once the power is applied, what do you do? Apply reset and
Hmm.
release.
Release.
Then what do you do?
And then the data income.
No, no, no. You
Step by
program the
step.
register. You need to program the registers,
Ah,
right?
okay.
It's like in a washing machine example. First thing you do after applying power is what? You program the
To
registers
program
by
what kind
turning
of
the knob. You're programming the
what
registers.
what
Then
kind
what do
of
you do
mode we
here?
required. Hmm.
What do you do? Once the programming of registers is done, what will you do is you will initiate the
Giving prior enumeration. Okay.
enumeration process. And after enumeration, what do you do? Once the enumeration is done, the virtual channel, what is that? Virtual channel initialization, right? Happens.
Okay.
You know VC0 initialization, VC0 to
VC7.
VC0 initialization. Do you understand the term? Like where
Yes.
the flow control initialization happens,
Yes.
where this layer and the other device, see, assuming this is one device, this other device, they both exchange their credits. This will tell how many
Hmm.
credits I have. This will tell how many credits it has got.
Buffer credits. Maybe
Buffer
they will exchange information how much space is available in both of the devices for incoming traffic.
Yes, and that all happens uh, after this one. Even before enumeration happens, what is the next thing that is involved? The
Link establishment.
link establishment, link training should have happened. So link training will indicate that, in fact, this should have been the right flow actually. Link training, the 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 DLL VIP indicates, DLL indicates link is up. And after that, virtual channel 0 to virtual channel 7 flow control installation happens. Enumeration starts as soon as VC0 initialization is done. Once virtual channel enumeration is completed, what will happen? Now the transaction layer is ready for normal memory write reads.
Okay.
The transaction layer is ready for memory write reads. This is where the processor will configure a set of registers in transaction layer to indicate, it needs to tell, right, where, because memory is very big. Now
Hmm.
my processor need to tell where in you need to read. That will be configured into this register. That register will tell to the DMA, from this specific point you need to read, and you get the data and give it to the transmitter. So that need to be configured, and that done even before itself. See, processor configures the set of registers here for uh, transmit and receive address, receive address in the memory. These are technically called as DMA descriptors. DMA transmit and receive descriptors. So once it is done, the transaction layer processes the descriptor. Transaction layer DMA processes the descriptors, DMA descriptors, and does the transfers as per these descriptor configuration. So this is the top level flow. Now, based on what TLP have generated, let's say, so the other side, the DLL and other components responds as per the TLPs that we generated.
Okay.
As per the TLP generated. Let's say we generated memory write. Tell me what will happen. Let's say I have generated memory write. What will happen here? Can you tell me?
In the transaction, in the transmitting side, if we generate memory write, and in the device B at some address, some
Yeah.
whatever the data we are getting from this DMA will be right into that address, and from the device B receiving from the device B transmitting side, we will get the uh, response. I mean
We
this
won't get.
right to
The
this
point is what? What we will do is
completion.
we will only get the acknowledgement. Completion won't come.
Okay,
It won't come. Why completion won't come? Because memory write is a posted write. If it is a posted write, there won't be any completion packets to that.
completion
Completion
package.
TLP will not come. Even ACK will not come. That's a mistake actually, because ACK only stops at data link layer level, right?
Yes, because
The
ACK is
data link layer
responsible for the
doesn't give
DLL
any DLL.
settings.
Yes,
Hmm.
exactly. Have you understood? Had it been memory write, sorry, had it been memory read, what would have happened?
Mhm.
Memory read request will go here. We would implement a buffer here. Okay, this is like an endpoint buffer. So from
Okay,
this, you frame the completion with data, and that completion packet data will come, and that will be stored
okay.
into the memory.
And because this is the non-posted,
Because memory read is a non-posted, so the completion packet is required for that.
it is required. Okay.
Yes, exactly.
Then what will be the response for the memory write because it is posted?
No, no response won't be there. See, memory write itself
Okay.
is a posted. That means for posted transaction, this transaction layer doesn't expect any response. It is already
Okay.
prepared. It's like sending a normal post. If you send normal
Sending a
post, do you
normal
expect
post.
any?
Yes.
You don't expect any
Yes.
response, right? Acknowledgement.
Understood.
Whereas,
If
let's say
if
you
we
send
read
one
from the
Telegram,
same, if we want to read from the same address which we have written before, then we will get the completion packet.
exactly.
Ah, okay.
Okay, so this is the top level flow, what we are trying to do. Why this is important? Because this is what translates into an FSM. You see, this
Interesting.
do you think, can I do this here? Can I do this here? Is it possible to reorder these
No,
things?
no.
Not possible, right? So I'm going to follow the same steps. Whatever is here, the FSM also has the same steps here. So now what we need to do is, based on this flow, we need to list down the FSM states. The first state will be idle state, because
Power down.
power down and applying power is nothing at the digital level, because
Yes.
we don't treat it as a digital part. It is all part of
Hmm.
the device initialize, device powering up. Okay, for us everything starts from here.
Yes.
Starts from 76. That is idle reset. Then what do you do? What is the next state? Register programming. What is the state? One state is idle, one is register programming.
It's a program.
Register programming initiated, register programming completed. What is the next state? Link
Link
training,
establishment.
link training
Okay.
initiated, link training completed.
Completed.
Then virtual
Virtual
channel
channel.
zero flow control initialization initiated.
So we have different states for different virtual channels. So 7 states.
Virtual channel flow control zero initialization completed. We may have to do same thing for VC1 to VC7, similar steps.
Yes. Yes.
Next, once it is done, enumeration.
Enumeration.
Enumeration completed. Okay, actually speaking, you may realize that completed state probably won't be required, because rather we may merge everything into one state called as enumeration itself. Because
Okay.
see, when you are in enumeration, you will do the enumeration. As soon as the enumeration is done, you will move to the next state. Okay, next state will be the idle state. I mean, the one kind of idle state. What kind of idle we will say? Enumeration completed idle. Enum complete idle state. Then at this point, you can go to various states like memory write,
Okay.
memory read, config write. I think enumeration itself was configuration write and configuration read, but let's still write it.
Yes,
Configuration
because
write.
enumeration has this specification numbers,
Yeah.
bus numbers,
Configuration write,
load,
configuration read, IO write, IO read, then
message, right? Messages,
messages,
messages.
some error state. I'm just writing down possible states. Can you think of any other states?
Is ECRC also a state? I mean CRC.
CRC. CRC will be part of memory write only. See, anytime you do memory write read, the CRC generation happens
Okay,
internally in memory.
the full data will be
Yes, yes,
in that
exactly.
part only. Okay.
Yeah. See, here itself, TLP framing also happens
Yes, yes.
in
In that
ECRC
framing,
generation.
the CRC generation and adding header, that's all takes place.
So the TLP header fields,
Hmm.
everything happens here itself. Inside each state, that will happen, and the transmit also happens. TLP framing happens, then TLP transmit
Yes,
also happens. Okay, similar to this, like this is about transmitting. You may need some receive states also to process
yes.
incoming TLP. Okay. Have you understood this
Yes,
till this point? Okay. So this is about FSM states, and this is important because this is what forms the backbone of our transaction layer RTL code.
yes. So
Now,
whatever we can do for the write or read up to the state 9, like enumeration state, from
yeah,
everything will be happening from this state. So this state 0 ideal to the state enumeration is common for everything,
yes, exactly, yeah,
whatever the transaction.
yes, exactly, yeah. Okay, so the only thing is, we said that at the micro architecture level, there are transmitter block, there is a receiver block, there is a DM engine. So these states may need to be grouped as per these components also, because
Sorry, sir, I didn't
transmit
understand.
itself will have its own state machine,
Okay.
receiver will have its own state machine. Do you agree with that, right? Because transmitter is
Yes,
again a
yes,
sequential
yes,
component. It will
yes,
have its own state machine. Receiver will have its own state machine. DMA engine will
yes,
have its own state machine. CSR
yes,
block
yes.
will have its own state machine. So that is the complexity. Probably we will not be doing RTL coding to that level, because if we go down to that level, RTL coding itself will take 2 to 3 months
It
of
is.
effort.
Yes, yes.
Our idea is not to go down to that extent. We'll try to create a scenario where it works essentially. Okay.
Hmm.
And where we are able to program the registers, we are able to frame the TLPs, and we are able to transmit the TLPs, and we are able to receive and process the TLPs. All that we'll do in one single Verilog module itself.
Okay.
So let's start off with the skeletal structure of the RTL code. So I think we are good, right? Okay, are we good to go with RTL coding now?
Yes, understood as of now.
Okay, so now what I'm going to do is PCIe transaction layer dot sv. Even though it could have been a Verilog code, I prefer system Verilog because system Verilog design has Verilog system Verilog has more design constructs, so it makes
Yes.
it more easy for me to develop the code. What it will be? Module PCIe transaction layer module. What all interfaces are there?
Interface with the processor,
Interface with the processor,
interface with the memory,
memory,
interface with the
DLL,
data link layer, and
RX,
all other.
DLL. So I will call
And
this as PX.
yes,
So, and I said that processor interface will be AX interface. AXI
yes.
means what? A clock, a reset. I'll keep active high only right now. A reset,
Hmm.
and all the channel signals: AW valid, AW ready, AW ID, AW address, AW len, AW burst, Other signals I won't keep. See, if you ask me, do I need AW cache,
No.
protection, lock? I won't keep because for now we are trying to create a code which is simple by adding all those signals.